Welcome to the Foundry by Forge College. In today's explainer, we're tackling a big one, Capstone, assemble and document the Foundry test suite. Now, coming right off our last lesson, drafting the case study, evidence, and arguments, you probably have tests, coverage reports, and optimization scripts just kind of sitting around. They're like loose bolts and gears scattered all over a messy garage floor. Well, our mission today is to take all that raw, chaotic material and build a finely tuned, fully documented testing engine. So let's dive right in and get this assembly line moving. Here's the blueprint for today's build. We're going to hit the final assembly line, defining capstone success criteria, merging and stabilizing tests, running tests and measuring gas, documenting for the handoff, and finally, verifying the final deliverable. Let's get to work.
Section 1. The final assembly line. Building the master blueprint.
Okay, so what's the actual goal here? We are essentially treating your disjointed tests and coverage reports as scattered machine parts that desperately need to be put together. The overarching point of this capstone is to build a highly reliable testing machine that you can confidently hand off. Because think about it, you really don't want to hand a future developer a literal box of loose wires and just say, hey, good luck. You want to hand them a turnkey engine where your strategy, your working cases, and your coverage improvements all live in one single cohesive suite. Section 2. Defining capstone success criteria. What makes a working machine?
Before we tighten even a single bolt, we really need to understand the exact specifications. So you have 4 mandatory acceptance criteria. First, total coverage of your core behaviors. Second, meeting your coverage thresholds. This proves you didn't just test the easy, happy paths. Third, your optimization insights absolutely must be reproducible and measurable. And finally, flawless end-to-end reliability. The whole suite has to run from a blank slate without crashing. No pressure, right?
Section 3. Merging and stabilizing tests. Putting the gears together.
Let's see how this translates to the actual assembly line, making sure our gears don't jam up on us. Step 1. Verify your environment and dependencies. Just make sure Foundry is properly installed. Step 2, you're going to merge those incremental tests into your canonical test directory. And step 3, this is crucial, you must resolve any duplicate fixtures and replace those chaotic, random seeds with fixed, deterministic ones in your setup file.
Now, if you're a bit new to the concept, here is determinism in a nutshell. It's a system's ability to produce the exact same output from a given starting condition every single time. To cure the dreaded, it works on my machine developer curse, achieving determinism isn't just nice to have, it's mandatory. If your test suite essentially flips a coin to decide whether it passes or fails, well, that's not a test suite, that's a casino.
Let's compare the two. Think of the nightmare of flaky tests as loose, rattling gears caused by non-deterministic seeds. They are guaranteed to fail unpredictably exactly when your reviewer runs them. On the flip side, we have deterministic, stabilized tests. These are locked gears. By exporting fixed seeds via a test config file, you're absolutely guaranteeing reliable execution across every single machine that runs the code.
Section 4. Running tests and measuring gas. Checking the dials and gauges.
With our gears locked in place, it is time to actually run the machine. Here is your exact sequence. First, start your local node with Anvil. Then, run your tests using the Forge test command with the gas report flag. After that, produce your coverage using Forge coverage and target the lcove reports format. Finally, convert that into HTML and save it securely right there in your deliverable directory. These are the core tools in your Web3 tool belt to capture hard, undeniable results. Honestly, proving your optimization is incredibly satisfying. Your optimization scripts, like benchmarking gas reuse, should clearly output exact metrics. You'll want to see your baseline gas pre-change, your beautifully lower after-change gas, and exactly where that sits compared to your expected threshold. This proves mathematically that your optimizations actually work in the real world. It's not just a claim, it's cold, hard data.
Section 5. Documenting for the handoff. Writing the operator's manual. Look, a beautifully assembled machine is completely useless if nobody else knows how to turn it on. Unless, of course, you plan on standing behind them whispering commands forever. You need to structure your documentation to map specific folders right to their purposes. Reviewers need to know immediately that the test directory is checked by running Forge test, the coverage directory holds the HTML index, and the optimization directory contains the reproducible scripts. You want to make it virtually impossible for them to get lost.
Inside your README testing file, make sure to include these critical elements: the prerequisites and exact execution commands, the expected script outputs, common failure modes with continuous integration snippets, and a simple reviewer checklist. Doing this ensures literally any peer can flawlessly reproduce your outputs without having to frantically message you at 2 a.m. for help.
Section 6. Verifying the final deliverable. The final QA checkpoint. All right, we've finally reached the very end of the assembly line. For this stage, you must use a fresh Git clone. No hidden local files saving the day here. You've got to pass these 4 checks from a completely blank slate. Check 1, all tests pass with 0 failed flags. Check 2, coverage successfully meets your thresholds. Check 3, optimization scripts run reliably. And check 4, the documentation is crystal clear. Pass all 4, and you've got yourself a solid machine. But hey, what if you're missing the mark somewhere? What if a test is still just a little bit flaky? Do not hide it. In software engineering, transparency is absolutely everything. Just document any partial completions in a delivery issues markdown file. Be sure to include exact reproduction steps and an estimated time for a fix. This way, the next team clearly understands the current trade-offs without any nasty surprises.
Once you've resolved those issues, or, if you totally aced it on the first try, you get to do the best part. When all checks pass, tag that branch with capstone ready. That single, simple tag signals to the world, to the next development team, and honestly to your future self that the master blueprint is fully verified.
Conclusion: ready for deployment environments. You have successfully taken a bunch of disjointed tests and transformed them into a deterministic, fully documented, and highly robust deliverable. So I'll leave you with this final provocative thought. Is your code actually finished when the logic is written? Or is it only truly finished when a total stranger can prove it works without asking you a single question? Ensure your seeds are locked, your gas is measured, and your docs are crystal clear. Be sure to visit forge.college to master the next phase of deployment environments and explore the platform for even more amazing Web3 concepts. Thanks for joining me on this explainer, and happy building.